In this video, we're going to talk about the second derivative. And we're going to use the same function that we used in the last video. And I want to reiterate that P is a resting point, and that is the local maximum, and Q is a local minimum. P is happening at negative 1 1/3, negative 1 1/3, 1.2, and Q is at the origin. And we talked a little bit about the second derivative. We found the derivative of the cubic function, the yellow graph, and we got the purple graph. And we talked about what it represents in the previous video. But we're going to move a little further now, and we're going to talk about the second derivative. And when you write it, one way to write it is f prime prime of x. And now we're going to take the derivative of the first derivative to give us the second derivative. So now we have 6x, because the 2 times the 3 gives you 6. So 6x plus 4. And if we graph the second derivative, we're going to get a linear equation. Not a linear equation. We're going to get a line. And here's the graph of the second derivative. And we're going to talk about what it can actually do for you. The second derivative, again, you can write it this way. This is how it's most commonly written, but I like the other way because it's just simpler to write. The f prime prime of x. 6x plus 4. And this is the orange graph. Not only is the orange graph the derivative of the purple graph, but it's going to give information about the resting points of the cubic, of P and Q. So, like I pointed out before, the x value of P is negative 1.3. Now let's follow that down, and let's see where that takes us. That takes us way below the x-axis. That means the value of it is a negative number. It doesn't matter what the number is. If it's below 0, that gives you some information about the function, about this cubic. And the information it gives is if the second derivative... Sorry, I'm at the school and kids are being loud. If this is less than 0, then that means it's a local maximum. Because what it means is you're going from a positive gradient to a negative gradient. And if it is greater than 0, then it is a local minimum. Because, greater than 0, because you're going from a negative gradient to a positive gradient. So the second derivative, the orange one, is giving us information about the yellow one. So if I put negative 1.3 in 4x, I'm going to get roughly negative 3.8, which is below 0, which makes sense because we're going from a positive slope to a negative slope. So if you have this scenario, if you put in an x value, then it tells you that it's a local maximum because it's less than 0, and therefore